What is the sum of 7 plus 3i plus negative 8 plus 9i? You can treat i's just like x's and combine like terms. So 7 plus negative 8 is a negative 1. 3i plus 9i is a 12i. The answer is A. Again, the sum of these complex numbers, 2 plus 4 is 6, and then 3i plus 8i is 11i. The first thing to do is to distribute this negative, which is really a negative 1, and it also is distributed over here to the negative 6i, so that becomes a positive 6i. The next thing to do is to recognize that because I is equal to the square root of negative 1, I squared is equal to negative 1. So we can replace this 9i squared with 9 times negative 1. And after we evaluate that, we're just combining like terms. 9 and 5 give us 14, 12i and 6i give us 18i. So the answer is D. I'm going to multiply these using the box method. So we have 14 minus 2i along the top, 7, 12i along the side. And when you multiply rows by columns, this is what you get. When you combine like terms, we get this, and we can replace I squared with what it's equal to, in other words, negative 1. So that part turns out to be a positive 24. So if we add that to 98, we get 122, and we still have 154i. To figure this one out and simplify it, we're going to multiply by another version of 1. If we multiply 8 plus 2i by 8 minus 2i, the i's will cancel out because we'll be left with an i squared, which will turn into a number. So that's how I knew to choose that one. I looked at this and I took the conjugate instead of plus 2i minus 2i. So then I'm going to do the box method for the top, you multiply straight across, and the box method for the bottom, you also multiply straight across. So when I multiply and combine like terms, I get this. Then I can replace I squared with negative 1. When I combine like terms, I get this. If I divide everything by 2, I get this, and I can split my fraction. So 7 over 34 minus 23 over 34. We can replace I squared with what it's equal to, negative 1. So now my numbers are 6, 8, and negative 3. So that gives me 11. And the 5i just carries down, and there's my answer.